Hello and welcome to Not a Buffalo, the show where we discuss the science and technology that will save the world. This will be the last episode of the first season of Not a Buffalo. After a fantastic first year, we've decided to take a break over the summer and we shall return in September 2020. Now for the show. My name's Ben and it's a glorious day wherever I am. This is Jack and it's always a glorious day where he is, because of his weather laser. Jack, how are you?
Yeah, I'm good. It's glorious without the weather laser too. Let's just appreciate nature, laser free, for once.
I don't know, I'm not used to nature anymore. I've been stuck inside so long. I don't think I could go anywhere without my trusty laser.
That's fair. Did you take your laser on your walk at the weekend?
I did. I got some strange looks, but at least people kept 2 meters away from me.
What you want your laser for, isn't it? Is to enforce social distancing when social distancing goes away.
I tried having a big hula hoop with spikes on it, but people just kept ducking under it. And coming in to give me a hug. We're really bad at the social distancing
When
thing
you
here.
said hula hoop, I imagined the crisp. I was imagining you in a very large hula hoop.
No, I'm in the plastic ring thing.
Oh, okay.
To be fair, it may have also been something to do with the fact that we made the spikes out of cardboard tubes, so they weren't particularly good.
Yeah. It sounds like Willow Twanky.
Oh yes,
the pantomime.
Yeah. Widow Twanky.
Yeah. That is esoteric reference number 1. Can you spot the other 42?
If anyone was going to guess where you're from, then that's a bit of a dead giveaway. Not that you're there anymore, so.
Yeah. I've run away from the theatre. They can't find me now.
Anyway, what's your first story for us, Jack? Have you got any good stories for us today?
Oh, it's my turn to begin things. So I'm going to begin at the beginning and then go on to the end, then stop. Esoteric reference number 2. My first story is about an ancient recipe that scientists have rediscovered. And this is probably veering towards the softer end of science, but I thought it was kind of a cool story. So
I love when my science is soft.
yeah, it's how you know it's done, and it doesn't get that crispy top layer. But yeah, so this Ben's laughing and it's putting me off. All over Europe, there are lots of medieval frescoes, which are fading, and they were made with paints from the medieval era. Although this may have escaped many people's attention, as it's happened over a 500-year time span, the way we make paint has changed. So the way we make some medieval colours, not only do we not do it anymore, but there isn't the knowledge of how to do it in some cases. And that was the case with this particular blue.
Can we not use that Microsoft eyedropper thing on Microsoft Paint and just test what the colour is and then do that?
You could, but then the paint might be damaging to the underlying layers, for example, or it might be too acidic for the existing undercoat or something like that. And so there's always a risk if you use a modern paint going to damage the fresco in some way. This blue has gone basically unused for 400, 500 years. And they found this book from the 15th century, which details the process of making this blue. And it's actually made from a little plant called Chrysophora tinctoria.
That was beautiful.
Thank you.
Ave Maria.
Chrysophora tinctoria is the tiny herb with a greeny silvery leaf, and they found it in Portugal. And so the way that they make this blue is they harvest very, very small fruits, what have to be pulped and processed in a certain way to produce this blue. And that's how they've been using science to fix medieval frescoes.
That's amazing. And are they replicating the process in a lab, or are they doing it are they replicating the process as they would have done it in medieval times? They're using no modern technology to do it?
No, they are replicating it using analytical techniques to zero in on the actual molecule structure. So that's how they're working out what the correct candidate molecules are and how they're checking it and everything. But yeah, it's not really like a pigment that's been used for a very long time. It's somewhere between the kind of indigo color used in denim jeans, but it's not quite like that.
Okay. How many colors? It's something like the human eye can see something like 14 million colors.
Yeah.
So I imagine you can get very, very varying shades of blue. It can vary very slightly, but it still makes a difference.
Yeah.
And we can still see the difference. What was that TV show? Time Team or something?
Oh.
Time Team Archaeology?
I loved Time Team. Who didn't love Time Team?
It was good, wasn't it? Time Team was great. So, ancient blue? Very old blue, anyway.
Yeah, middle into ancient.
Yeah, and a lot of those medieval frescoes aren't really helped by the amount of air pollution that we have at the moment.
Yeah, I hear that the pollution is like 3 or 4 times worse when you're inside a Segway.
It can be, but luckily, I actually want to share 2 news stories that have happened recently, because they're kind of linked together. But the first one is that they've calculated, and by they, I mean the Centre for Research on Energy and Clean Air, based in Europe, has calculated there'll be 11,000 fewer deaths in European countries because of the recent sharp drop in fossil fuel pollution.
Oh, man. That's fantastic.
11,000 avoided deaths is what they've calculated so far.
That's really good. If only we knew what was driving this downturn in fuel usage.
I know, it's a mystery, but I mean, maybe we'll never know.
We are going to be the worst podcast for archaeology, aren't we?
Yeah, we are.
Future archaeologists are going to hate us.
Yeah. They are. So just a couple of really interesting things here is apparently... So yeah, the World Health Organization had calculated that about 4.2 million people die every year due to air pollution, although recent studies have shown that it actually has an impact on cardiovascular disease, so it could be as many as 8.8 million premature deaths and shortening lifespans by nearly 3 years on average all around the world. So the fact that we're saving 11,000 people from the drop in pollution alone is fantastic. Not
to mention the environmental benefits, right?
Exactly. And that's actually kind of the segue to my next story. Thank you, Jack.
My pleasure.
So on beaches in India, there is a species of turtle called the Oliver Ridley turtle, which makes their nests and lays eggs on beaches in southeastern India. And they used to just come onto the beach during the night and lay their eggs in the sand. But because the beaches have been empty recently, apparently thousands upon thousands of turtles were coming onto the beaches and laying their eggs during the day. And then after about 45 days, the eggs hatch. And they said that there's been millions more baby turtles have survived and hatched and are returning to the sea as we speak. So the millions and millions of baby turtles that have come about because the beaches have been empty and the turtles are feeling clearly a lot safer and happier. So huge environmental benefit there. I think they had these Oliver Ridley turtles that only had a very small number of rookeries, they're called, where they actually went to lay their eggs in early spring, and the fact that the rookeries are in better condition than they were beforehand is just a huge boon for them.
Yeah, this is awesome.
2 really nice good stories I just want to start off with.
I love the way that just by removing human beings for like a little bit and for human beings taking a little step back, we don't have to go away completely, but by just taking a little step back, the planet is able to just thrive in a way that I guess it doesn't seem obvious.
It does give me a lot of hope that we haven't done irreparable damage, and if we do make some changes, we could see the world flourish a lot more.
It seems savable, doesn't it?
Yeah.
That's what I like. I like the way this is all about hope.
Yeah. And that's kind of the one thing we want to do in this podcast, really, is as we said, the next time someone says that the world is going to heck, then we want you to say, give Not a Buffalo a listen, because you'll think otherwise when you hear about all the great things that are happening in the world in science and technology.
On the subject of hope, this is a story about one scientist's hopes being dashed. The headline, which rather grabbed my attention, was "Why Otters Juggle Rocks is Still a Mystery."
Oh no, I thought we'd cracked that. I thought we'd solved the case.
I know, right? This is what we were all hoping for. But yeah, this adorably cute otter, which is juggling a small stone in his tiny human-like otter hands. It's still a mystery as to why he does that.
But I can see the joy on Jack's face. So we thought we had figured it out.
Well, there was a theory. Not all otters use their paws in the same way. And the idea was that this juggling of rocks was a way of them maintaining their dexterity in their paws, right? And so they thought that, well, there's a couple of species of otters eat crustaceans, and so they need to claw them open, basically, and there are others which just eat fish and don't eat things which involve that kind of dexterity. And the theory was that those which require that extra level of dexterity would be practicing this rock juggling, and the ones who just ate fish would even if they did do it, they wouldn't be as good at it because they wouldn't require that level of dexterity. And after a very long period of study, I think it's several months of studying otters in different locations around the world, the science is in, there isn't really a difference in the juggling.
I think they need to take this further. They need to give the Otters PlayStations so they can test the dexterity using those.
This is what I want to be part of. This is what first drew me towards science.
Here on Not a Buffalo, we ask the hard questions like, can an otter play a PlayStation? And which species is better? You know, another thing we could get the otters to try, actually, is we could try seeing if they're any good at controlling cardboard probes.
I think I'm going to like where this goes, assuming this is like a space probe made of cardboard.
Kind of, yeah.
Okay.
You may be aware that in summer 2020, NASA is planning to launch its next Mars rover called Perseverance.
Yeah.
And they wanted to carry the first ever aircraft to fly on another planet, which they've inventively called the Mars helicopter.
NASA are boring sometimes, aren't they?
Yeah, and the thing is, this helicopter will carry no instruments and collect no data. They just want to see if they can fly it. They're basically sending a toy drone to Mars to see if they can.
I like it. I like it very much.
But the thing is, engineers at the University of Pennsylvania have got a better idea, which is to use tiny nano-cardboard flyers instead.
Nano-cardboard?
Yeah, so what happens is when a bright light is shone upon it, one side of it heats up, and then the temperature differential causes air to circulate through the structure, and it's like cardboard, so it's like corrugated cardboard, and then the air shoots out of the channels and allows them to fly, and they weigh about a third of a milligram, so they're absolutely tiny. But that means that you could send millions of them basically in place of this Mars helicopter. So yeah, it'd take about 1 million of them to equal the mass of the Mars helicopter, and more than 6 billion to equal the ground-based rover that they're going to fly in. So they're a lot more effective that way. But also it means that rather than having one very complicated machine where like a few grains of sand in the wrong place could cause it to blow up. Probably a bit dramatic, but you get what I'm saying.
Yeah, exactly.
You could send hundreds of thousands of these things, then you have hundreds of thousands of chances to go out, and you could put tiny sensors on them. That's what they're trying to do at the moment, is they're trying to miniaturize sensors that you can attach to these things and then send them off in all directions. They could even maybe pick up tiny samples of Martian dust and then fly them back to the rover and everything. And it's just a really cool idea. Like, I just love the idea that they're in NASA and someone comes in with a really complicated design and spends like 3 hours presenting how they're going to get a helicopter to work, and then someone just throws a paper plane at them and says, try this instead.
That's a great story.
It is really cool, isn't it?
If they're going to maybe pick up samples, is there like a directional thing on an ability to control their direction, or is it entirely just power-based?
Yeah, so they're looking at that at the moment. So the idea is they're actually, because Mars has lower gravity and because the atmosphere is thinner, these tiny paper planes can actually carry a lot more, nanocardboard planes can carry a lot more than they would be able to on Earth.
That's amazing.
Yeah, I mean, unfortunately, because they only weigh a third of a milligram, that still means that they can only carry something that weighs a few milligrams, which is still like quite a few times more than them. Like, it'd be like a plane carrying like 50 elephants or something like that.
Or 5 planes.
Or 5, yeah, it'd be like a plane carrying 5 planes. That's much better.
For the visuals out there, yeah.
And so the way they'd actually steer them is they could use a laser. So they could use point a laser at it, heat up different parts of it to get it to steer, and they can stick a laser on the rover and do that. So that's why that's the kind of idea that they're thinking about at the moment. They also said it could possibly use an Earth in the mesosphere, because that at the moment that's too high for planes and balloons and too low for satellites, so we could put them up in there as well, because they do great at there, because the gravity is less and the atmosphere is thinner, so they could do a good job up there.
And I suppose you could also test them there as well. I don't know, is the mesosphere comparable to Mars's atmosphere at ground level?
The atmosphere level is similar. I think the gravity is still higher here on Earth than it would be on Mars. But yeah, in terms of density, the atmosphere is pretty similar.
That's really cool. That's a really cool story. I like that.
Yeah, it was the visual that came into my head of just a scientist out at the back just throwing paper planes and someone going, that's a much better idea. I should say at the moment, I think they are still going with the helicopter because they haven't worked out all of the bugs with these little nano-cardboard flyers.
It almost sounds like they don't want to go with the helicopter, though, if they're willing to consider the concept of paper planes.
I mean, I think given NASA's track record, if you say to the person managing the budget, like, okay, yeah, here's 100,000 really cheap things we could make, and we've got 100,000 chances at it, as opposed to here's one machine that if it goes wrong, we're kind of screwed, and also it has no sensors and won't collect any data anyway.
They'll go for the one that doesn't record any data anyway, right? That's
probably. But who knows? Who knows? So yeah, that was. I just came across that story and just really liked it. Yeah. So you got another story for us?
Yeah, because I heard Mars is really cold, right? Do you know what's colder?
Not Saturn, as we learned in the last episode.
Yeah, because Saturn is a toaster. See previous episode. So what is colder is the temperatures required for quantum computing.
Oh, yes.
Yeah. At the moment, most quantum computers require that you're dealing with levels at a fraction of a degree above absolute zero. So you're talking about 0.01 degrees above absolute zero.
In the correct system, of course.
Yes, exactly. Millikelvin.
Yes.
In this case. So it's very, very cold, basically. And one of the issues we're having is that it needs to be able to operate at slightly higher temperatures, and a team of scientists have actually managed to do this. Don't hold your breath too much, because I did, and I was like, oh wow, that's really impressive. They've actually got it to be just over 1 degree above absolute zero, which is a massive improvement when you think they're looking at 0.01 degrees. That's like more than 100 times warmer.
That is pretty impressive, yeah. That is a big improvement, but I imagine it's still quite difficult to cool things down to 1 degree above absolute zero.
It is, but it's a hell of a lot easier than 0.01 degrees. You have this sort of logarithmic effect of effort that you need to put in as you get down towards very, very low temperatures. It becomes increasingly harder to lower the temperature, basically because you're fighting the laws of thermodynamics, in particular entropy.
That is amazing, and quantum computing would be, once we've kind of figured that out, we can make huge leaps in terms of computing power and things like that in the world, wouldn't we? They're just vastly better than a normal computer.
Yeah, well,
once we've actually got them working.
Yeah, exactly. And from a point of view of security and cryptography and information processing about the quantum realm, like this, getting quantum computers up to a scale where they can do interesting things is going to be amazing.
Well, that is really amazing. And I actually have a story about breaking through security.
What did you do?
Have you ever heard of the blood-brain barrier?
Yes. Yeah.
So that protects the brain from all the nasty stuff that tries to get to the brain, things like viruses and bacteria and stuff like that. But it kind of gets in the way when we want to repair the brain. So things like Alzheimer's that causes plaques to form in the brain, epilepsy, brain tumours. I mean doctors. Don't let me do it. It'd be a bad idea. They sometimes need to get through the blood-brain barrier to the brain so that they can deliver more effective treatments. And that's really difficult to do and quite risky as well. But Richard J. Price of University of Virginia's School of Medicine has found a way to use focused sound waves to overcome the natural barrier.
Okay, just to sort of disrupt it through some kind of frequency.
Yeah, I mean, it kind of reminds me of Banshee from X-Men.
Yeah.
They can use really focused ultrasound waves to basically create a little hole in the blood-brain barrier, and then they use an MRI to guide it and know what they're looking at, so magnetic resonance imaging. And they can then, the example they used here is gene therapy, and using nanoparticles, they can inject new genes to help repair the damage caused by, for example, a brain tumor, so they use that as one of the main examples. Oh, that's amazing.
Without having to cut the head open or anything like that. Yeah,
exactly. So yeah, they basically don't have to cut through the skull or anything, which if you've ever seen a medical show or an actual brain surgery, like they have to use a big electric saw to get through the skull. Like it's a pretty tough thing, and it's kind of terrifying, someone having that close to your head. Yeah, they can basically use these deep penetrating nanoparticles, inject them into the brain to the specific tissue that they're targeting, and deliver this kind of gene therapy, which is essentially strands of DNA that they can use to fix other strands of DNA. And they're already using it. Where was it? So apparently they've already been using it in labs to treat conditions such as Parkinson's, the tremor you get from Parkinson's.
That's amazing. One of the things I love about doing this show with you is that no matter how much I read and I talk about science still feels like science fiction sometimes, and this is one of those stories. Yeah,
and I know this is probably just because the time we're in, and I feel like things feel more and more like science fiction now. If you showed me a mobile phone back in the 1960s, I'd have gone, "Oh, that's kind of cool," but I wouldn't have felt it was that science fiction-y. But now the stuff is like properly insane, like future aliens, like we're that close to crossing light speed and being able to heal ourselves at the snap of our fingers kind of technology.
Yeah. It's almost as though science fiction has kind of run out of ideas and is at the stage where it's like science is actually catching up with mainstream science fiction, which is just mad but so cool.
It is one of the really interesting things. I read Isaac Asimov's Foundation trilogy, or Foundation series, entire series.
Oh,
actually.
I've not read the full series.
In the first one he wrote, Foundation, which was written like 1968 or something, and you compare it to now, and you can see the way he talks about computers is you can see he never really was exposed to the kind of computer we are now. Even the technology now that we have now seems so much more advanced than what they have in Foundation, even though it's set tens of thousands of years in the future and things like that. So it is incredible. I mean, that's the mark of a really good science fiction writer, I think, is someone who can look at what we have now and come up with something that's believable but so beyond of what we can imagine now, where so many things like, oh yeah, I can imagine that, or and some bad science fiction look at it and think, why don't they just have communicators? Like that. Just I was watching the other thing, Red Dwarf by the BBC, an old TV
That's
series
so good.
from the 90s.
I love Red Dwarf.
And again, you're just looking at things like they have that technology, which makes sense, and I can see that being advanced. But other things, you think, why don't they have a solution for that we have already? I can't think of a good example now, but like they have the food things that can just create any food, any meal you want just by asking for it. But then none of them seem to have communicators that can go between the rooms or across the ships, and none of them have handheld communicators. Yeah, which is really odd when we all do now.
It's like everything's a white label appliance, isn't it? In Red Dwarf, everything's something that has to be plumbed into the wall. And the people are just people. I always loved one thing that they did, which we're sort of in the middle of doing now as a civilization, which is they put AI in everything. So they have a toaster which has artificial intelligence in it and suffers from depression as a result. That's
my point. Like, they predicted the Internet of Things, but then they didn't predict mobile phones or smartphones. Which is,
it's funny, isn't it?
Yeah, and I think that is one of the things that does just mark a good science fiction writer. They can kind of go, what kind of problems will we have in the future, and what kind of solutions will we have come up with to things that aren't even a concept of a problem right now.
It's kind of an extrapolation process, I think, science fiction. Like, it's always sort of takes the present as its start, or usually takes the present as its starting point. I think some of the most interesting stuff is the stuff that's sort of slightly alternate history of science fiction. So where something really weird happened in 1919 and reality there splits off, and then we're in an alternate 2020, something like that. It's still a case of like taking that point and then extrapolating to what happens logically there.
Yeah, and I imagine it comes down even personally down to the actual writer themselves, the kind of things that they've seen and the problems or the issues they see in society and how we might think of how to make them better. But it's just it is a fascinating thing to look at.
Yeah, I always love reading H.G. Wells because that's so of its time and of its technology, and it's prior to flight in a lot of cases. He would have been aware of that kind of push to try and get manned flight be a thing. But at the same time, balloons were really what he knew. That was kind of that was the height of aeronautical technology to him. And so when you look at what he sort of predicts, that's really interesting because it's based on a Victorian idea of technology and takes its off point from there. I think we're getting a little bit sidetracked. Do you have any more stories, Ben?
I have one more I'd like to mention quickly, if you don't have any more.
No, I do have one more, actually, which is kind of a fun one to end on. So physicists have found a way to overcome the classic Non Newtonian effect of mixing cornstarch and water together. So, cornstarch and water, if you mix them together, you walk on them and they're solid on impact, but if you stand still, you sink, right? So what they've discovered is that, very similar to your story about the blood-brain barrier, there is a particular frequency that you can fire at this liquid which will make it completely liquid because it disrupts that bonding on impact.
Oh, wow.
So now there is a good reason to trick your friends into trying to walk on cornstarch and water and also buying an expensive high-frequency oscillator because you can then watch them sink and then you can turn it off and it will be solid.
As if I needed another reason.
I don't know if this is really worth the funding of science at this stage, but
Well, did you ever see, there's a TV show called Brainiac, Science Abuse, and they did this experiment where they filled a swimming pool with custard, like not an edible custard, I don't think, basically just cornstarch and water. It was more like that, but they actually got a guy called John Tickle, which is a great name for a presenter, to walk on it. But then I love the fact that they told him to stop walking so he'd sink so they could show that it does turn into a liquid, but then they couldn't get him out again.
Yeah, he was totally stuck, wasn't he?
You could see like the whole crew tugging on him and they couldn't pull him out.
That was a good show.
My last story is also about something acting in a way that you wouldn't expect it to act.
Is it me?
It's not you,
Okay.
no. You have not been studied that extensively by science
Thank
just
God.
yet. The studies are ongoing. But have you ever heard of mycelium?
No, remind me. I do know the name, but I don't know what it is.
Yeah, so mycelium is the kind of underground fibers that link together mushrooms.
Yeah.
So the toadstools that you see on the ground are the fruiting parts of this, and mycelium is the underground
They're like
stuff.
the network that link it all together, and that's how they're enormous organisms, isn't it? Because mushrooms are enormous organisms spread over enormous distances.
Yeah, exactly. But the thing is, it's a very flexible material, so it can grow and form around anything. Basically, that's how it's able to spread out through the forest. And so this woman from Nebraska, this woman named Katie Ayers, decided to see if she could make a canoe out of it.
I love it.
She created a wire skeleton and she put it into a special room with temperatures in the wrong system, so I'm not even going to bother telling you,
Yeah.
and 100% humidity. And she basically sculpted the mushroom and got it to grow around the wire skeleton. It took about 90 days, covered the entire skeleton, and then she dried it out. She calls it My Canoe, which is a pretty good name.
I like this so much.
But then, she dried it out in the sun, and she now paddles in it like it's a fully working canoe. Mycelium is waterproof once it was dried out, and it's pretty lightweight. And so she's grown an organic canoe.
That's amazing. Is it flexible? Like, how durable is mycelium?
Like, it seems pretty durable. Once it's dried out, I think it becomes pretty rubbery.
Oh, that makes
So it'd be like having a fairly, and it's quite thick as well. Like, she grew quite thickly around the wire frame. So I'd say it's pretty similar to a normal canoe in terms of being fairly solid rubber with a bit of give in it, but still. Yeah, well, apparently they're exploring mycelium quite a lot. Someone has started looking at creating compostable car parts out of mycelium.
That's great. That's a great idea.
So yeah, it's just a wonder material and delicious as well. My partner actually hates mushrooms, but I love them. I think they're delicious.
Mushrooms are fantastic.
Yeah. Next time you need a canoe, just give yourself 90 days in a really hot, humid room, and
In Nebraska.
that's all you need. The advantage of being Nebraska is you could just leave it outside to dry over the summer, and that's how she dried it out.
Is this whole podcast a way of you convincing me to move to Nebraska?
No,
Okay.
I wouldn't move to Nebraska.
Okay.
Like, it's quite nice weather, but everyone has guns.
Okay. I won't move to Nebraska this week.
You're your own man. And who says you're not in Nebraska now? I don't know.
Oh yeah, that's right. People don't know that I'm not in Nebraska.
I mean, we've eliminated 2 places now.
What was the other one?
Well, you mentioned Widow Twanky, and then we mentioned you don't live there anymore.
Oh
so
yeah.
they know you don't live in Nebraska or the theatre.
I imagine that there's somebody out there mapping out all the places we rule out, region by region, over the course of this podcast, and eventually they will be the person who writes into us.
They'll write to our address, like handwritten notes.
Because they've eliminated all the other houses, right? So
Yeah. No, because they found our house, because they've eliminated every other house in every other country.
this seems doable, right? This is a fun project for anyone listening. Please don't do this.
We may have to do a number more episodes, though. I'm not sure we've given you enough clues just yet.
Yeah, so I guess that's a good reason to come back for season 2, right?
Yes, absolutely. And with that, Jack, do you want to take us out at the end of season 1?
Thank you very much for listening. Please subscribe to the show to never miss an episode, and rate and review us wherever you have the power to do so. If you'd like to get in touch, we are at Not a Buffalo Pod on Twitter and Instagram, Not a Buffalo Podcast on Facebook, or contact us through the website, notabuffalo.wordpress.com. And we look forward to discussing more great science and technology with you in September. Bye.
See you in September.